So in the previous class, we did VPN, which is a layer 3 VPN, and we got two customers. One is Tinku on the left and the right. Another one is Binku on the left and the right. Uh, luckily we were running BGP between Tinku and ISP and Binku and ISP. Because it is BGP and the tunnel is also BGP, you are lucky. So this eBGP was pushing the route through the tunnel, and from the tunnel it was given to remote eBGP. So the distribution of route was easy because it was end-to-end BGP. End-to-end BGP. So from here to here, one BGP, which is uh, between the customer and the provider, eBGP, and then within the provider you had IBGP, and then again between the remote customer and the ISP it was BGP, and it was easy for us end to end because it's the same protocol, only the autonomous system number was different. It's the same protocol BGP. The distribution of route was easy. But what if we have customers telling that we don't want to buy BGP, we don't have any autonomous system? What if a customer says, why should I go for BGP when I don't have multi-homing? He's got a valid point, All these guys are saying, you see, we are not going for BGP. We don't want BGP. Customer Tinku and Binku, they are very sound technically. So they say, hey, no, come on, don't want BGP. Boom. That's all. I have seen such customers very clear in their decision. I have my friend company, means, it's a government company. My friend is a CTO there, an African friend. He said, no, Jay, no MPLS. Sorry, we don't want MPLS. Why? Why there is need for MPLS? See, we just got 4 device. We just got 4 device. Why do we need MPLS? No. We don't want MPLS. He's correct. I said, let us learn in future. No. We don't want. He's like that. Very clear in what he has got and what he wants. So this customer Tinku and Binku is also same like my friend in Kanarki, Guinea. What Tinku and Binku says is he got only one ISP. We don't have multi-homing. We don't have any policy. Just the route to get distributed from left-hand side to the right-hand side. So we will use OSPF. Tinku says OSPF. And Binku says, come on, who wants OSPF? I don't like OSPF. I'll rather go with ISIS or I'll go with EIGRP. Did I cover ISIS for this batch, Sai? So your batch, did I cover ISIS? No, we haven't started. Okay, later. We'll do it later. We'll do later. So I'm not going to do ISIS because we don't know much about ISIS in this batch. So I'm going to have EIGRP. That's what Binku says. Binku, you're right. Let's go with EIGRP, Autonomous System 10. And comes Binku on the remote side saying, hey, no. See, I don't care what Binku in the left says. I don't like EIGRP. I like only REAP. routing information protocol RIP. So they all have their own views, what to use, why to use. So we can't force them as an ISP. You need to provide service, whether they have OSPF or RIP or EIGRP. We cannot force them to switch to some other protocol as per your desire. They have their own wish, rights. Okay, what is next? We'll see how to take the OSPF route, give it to VPN, so that the routes will go to the remote site. Now, let's talk about OSPF sometime. We all know OSPF. OSPF has got the hierarchical design. We will have area 0 to which other areas will be connected. But in my case, you see, I have OSPF 100, OSPF 200. In the middle, I'm not having OSPF. See, I do have OSPF for R3 pinging R6. That is not the OSPF. What I'm trying to say is I'm not going to have OSPF over the tunnel. Tunnel is BGP. You know, we all know that. And I'm asking you a question. Please think and tell me, if I run OSPF here, will this OSPF and will this OSPF that I'm running here, see carefully, ask me question if you don't understand. The OSPF that is running here, the OSPF running here, will it be same or different?
It should be different.
Why?
Because you know,
Because the control plane is different. Because the control plane is different. This is
want these routes to be.
This is different routing table. This is another different routing table. This interface is connected to Tinku VRF. This interface is connected to default VRF. So they cannot mix. So what I'm trying to say is the OSPF running here is not going to act as a backbone for your OSPF from Tinku. Tinku comes in this link, takes the VPN, and then goes out on this link. These OSPF running on this physical link has got no connection. So then, how can area 100 give routes to area 200 without area 0? That is what I want you to think and think. I'm not expecting an answer. I'm just asking you to think. OSPF.
Could you ask the question?
OSPF has got a hierarchical design. Every non-backbone areas communicate only through backbone area. All areas should give routes to area 0, and only through area 0 one area will know about the networks of the other area. This we know. Area learns route from other area. Only through area 0. But here we don't have area 0. In the left we have area 100. On the right we have area 200. We don't have area 0. Then how this communication is going to happen? Answer is
different OSPF, right? the OSPF which we have within ISP is different to the OSPF which we are using on the customer side.
That's what I'm saying.
Yeah. So
That part is over. No, now my question is, in general, if two area needs to communicate, like area 100 and area 200, what is needed in between?
area 0 backbone.
But do we have area 0? No. We have what? A VPN. We don't have area 0. We have layer 3 MPLS VPN. Now, what I want to tell you is, this layer 3 MPLS VPN will act as a super backbone area. So you no need area 0 to connect between area 100 and area 200. That's what I want to say. You should not think in that perspective like two non-backbone areas. They need backbone area. Don't think like that. You don't need backbone area because VPN itself will act as a super backbone. So this VPN is made of BGP. BGP will take a route from area 100 and transport it to the other end, area 200. That acts as a transit area, area 0. VPN is acting as a super backbone. Okay, that part, I want you to be very clear. Now let us move on to the next thing. How we are going to achieve this? What we need to do is
Using redistribution.
correct. We have to redistribute. No other option. But where are you going to redistribute? Under BGP. No, under which BGP? Under the VRF of Tinku. Because we have a separate control plane now. For Tinku, the VPN is the link, not the physical link. So only when I redistribute the OSP route into VPN and then back from VPN to the OSPF, this is going to happen. That's how the connectivity goes. I'm going to show you this first. Then we'll go to RIP and EAGRP. First, let us do Tinku. I'm going to replace this with OSPF 100. OSPF 200. Right, let me start from router 1. I'm going to remove BGP from here. You see, no router BGP 100. This was the earlier. I removed it. Now I should not see BGP here. Show IP BGP. BGP is not active. That's nice. I would like to do the same removal of BGP on the right hand side. Show. No. Next. Let's go to router 3. And here I'm going to say, first let me show you. We have put the neighbor activation under the VPN. Under the VRF. That is what I'm going to remove. The thing I configured, neighbor I configured under the VRF thing. So do show run section router BGP. This is what I want to remove, 13.13.13.1 under this address family. So this is on router 3. Don't remove BGP here. This is ISP. Router BGP 10. Only go inside this address family and remove this. Tinku. Done. Likewise on R2. Sorry, R6. Router BGP 10. No. Go inside this Tinku. Done. So we are going to now put OSPF on either side. Let me start from router 6. Okay. I'm on router 6, which already runs OSPF, but that OSPF is working for the default routing table. So you should not use that OSPF. See what will happen if you try to use the same OSPF. See what will happen. I'll show you. I'm going to interface G3/0. Please answer this question. Is this interface a member of global routing table or VRF Tinku? I'm in router 6. My question is, this interface G3/0, is this a member of VRF Tinku or global routing table? Come on, why you take so long, please? If you don't know, you say you don't know. You don't know? Okay. If you don't know, I'll show you. Do show IP VRF. You see, it's a member of a VRF called Tinku. Okay. So now I'm going to the VRF interface and saying IP OSPF 1 area 200. See what will happen. It will not accept. Yeah. It won't accept. Why? VRF specified does not match the existing router, meaning this interface, this G3/0, this particular interface is a member of Tinku, not the global routing table. The default routing table. This is what it says. Hey, this interface belongs to default route. This OSPF that you are trying to say, OSPF 1, it is running already in the default VRF. and it is not matching with the existing VRF called Tinku. That's called router, existing router, virtual router. So I have to create another OSPF. You see, IP OSPF 2 area 200. Now it will accept. See, we should not use the same OSPF that you are running on the default routing table. Default routing table, default VRF. So default VRF, yeah, it will mix. No, if you run same OSPF, then this routing table and that routing table will get merged. Your internal network and customer network will get mixed. Is that okay for you? Hmm? So you should enable another OSPF. If you try to use the same OSPF, first of all, it won't allow um, because it will get mixed. It's against the control plane policy. You have two control plane, and how can you have one common routing protocol for two control plane? Not possible. VRF is one control plane. Global routing table is another control plane. The default routing table. The default routing table has got OSPF1 already running. So we have to use another OSPF. Alright, now next is what? I'll show you the routing table here before I configure OSPF on customer side. I'll show you show IPVRF. Tinku. Right. Show IP route VRF Tinku. You see, there is no route from the customer side. See, there is no route from the customer side because we have not enabled OSPF on R2. Let's go and run OSPF on R2. Alright, this is interface loopback 0, IP OSPF1, area. Here, this OSPF process ID is locally significant, so don't worry. Don't think like, oh, I gave 2 there, I should give 2 here. No, it's just a process ID. Only the area should match. What is the area? 200, not 0. Likewise, interface G3/0. Now you will see neighbor coming up. Look at this, neighbor has come up. Through VRF, see, here also OSPF has come, and if you check the routing table now, you have learned the customer route inside this table called VRF Tinku routing table. Likewise, I'm going to do on the left hand side. On R1, we are going to run OSPF. Interface loopback 0 IP OSPF1 area 100. Interface G3/0 IP OSPF1 area 100. Now going to router 3. Interface G3/0 IP OSPF2 area 100. Don't forget. You should put area OSPF2 process ID. I'm expecting a neighborship between R1 and R3 now. This process ID here, it is 1, and here I'm giving 2. That is okay. By this time I should see neighbor, but why am I not able to see? Show IP OSP of neighbor. It's an extra state. Give some time, it will come. Yeah, neighbor has come. Please try understanding. So far what we have done is
Jay, one question. So G3/0 on router 3, that interface will still be part of the VRF Tinku, right?
It should be. Yeah, see. Show IP VRF G3/0 is Tinku. Show IP OSPF interface brief. You see this G3/0 belong to process ID 2, not process ID 1. Look at this. Even the inside I don't have area 0, it is area 100. That doesn't matter anyhow for us. That is a different OSPF. So here there is no area 0 anywhere. So don't think that we have area 0 in between 100 and 200. No. In normal OSPF, you must have area 0 between 100 and 200. But in MPLS layer 3 VPN, because the VPN can act as a layer, as a backbone layer, as a area 0 super backbone, you no need area 0.
So because G3/0 is part of a VRF, so it does not, the control plane of the rest of the routers in the ISP and R3 will not be mixed, because on R3, R4, R5, R6, using OSPF area 100, we have.
But process ID is 1.
Okay, the process ID makes it.
So the route learned from process ID 1 won't be given to process ID 2. First the process ID, and then only the area ID. Next. Let us now see how to take the route of Tinku in the left to the route of Tinku in the right. In the left, we have the OSPF neighborship, and I can see the route in the routing table, show IP route VRF Tinku. We have this route 1111, but this need to now go, this update needs to go through the VPN, so that in R6 VRF routing table, I'll be seeing 111. But as of now, no redistribution, so no, you don't see. Let's see how to do it. First of all, I want to give it to the VPN, this 111. And later I want to take it from VPN and give it to the routing table. So VPN is made of BGP. So go to BGP, route to BGP 1 and 10. Route to BGP 10. Address family IPv4 VRF Tinku -L. And here I need to say redistribute OSPF process ID 2. That's all. As a result, if you go to router 6 now, you will see 11111. Look at this, it has come through IBGP. Through IBGP. You can also see that in the table show BGP, VPN v4, unicast, VRF, Tinku, You see 1111 has come. And this is what I want you to note. The metric is the metric of OSPF. When you redistribute OSPF into BGP, and when BGP acts as a super backbone, the metric, the cost of OSPF is copied as MED of BGP. Only between OSPF and BGP, this is possible. And because it's a redistributed routes, you see, question mark, which is incomplete. That's the origin type. We learned this BGP long back. Instead of I, it is question mark. Now, will I be seeing this in router 2? No. Because from VPN, BGP, you have learned this in this routing table. But to give it to router 2, you should speak in OSPF language. So I'm going to say to OSPF, router, please focus. This is something new which I have not seen before. Router OSPF to VRF Tinku. This is, I think, spelling mistake.
R, I think.
Huh?
Tinku-R.
Hyphen right side, correct. Now here I should say redistribute BGP 10.
No, we're using OSPF 1, right? Process ID.
No, OSPF 1 is the ISP's OSPF.
Okay, this is good.
That's why I say I put VRF.
Correct.
Now I need to say redistribute BGP 10. Okay, I need to say subnets. As a result, you will find router 2 with a root. And you also see the number of the cost, the OSPF cost.
The syntax is redistribute BGP AS number.
Subnet. No need to mention VRF because we have already mentioned VRF on the top. So only from that VRF of BGP it will get it, not from other BGP. Fine. Now I need to do the same work on R3 so that R1 can learn the root. R1 right now don't have root to 2222. So I need to go to R3 OSPF router OSPF to VRF Tinku -left. Redistribute BGP 10 subnets. Now if you go to router 1, you will be able to reach router 2. What? Wait a minute. I didn't do one more thing. The route from R2 is given to R6. That you need to place it into BGP VPN. We have not done that in this side. We have not done that export. Router BGP 10 address family IPv4 VRF think on the right. Redistribute OSPF process ID 2. That's all. Now going to router 1, I should see the routes. And I can ping now 2222 very well. Trace route. You'll see labels are in bold. The VPN label and the service label and the transfer label, VPN label, and the transport label. Okay, it has gone now to ISP. Now ISP is going to add two labels before sending to router 4. Right now packet is in router 3. See, the two labels are 12 and 16, and sorry, 20 and 16. Only from label numbers 15 onwards it is allowed to use. And 19 is the label for reaching 6.6.6.6 in R5. And R5 has done PHP. Label number 16 is what given to customer Tinku. At last it goes to Tinku. I see, because you have not done the previous lab, this is going more challenging now. Right, the VPN configuration is very simple. Under BGP we say address family VPN v4, show RAN section BGP, sorry, router BGP. This is what the VPN configuration, very simple.
Okay, we don't call the VRF.
No. VPN is like a trunk link.
Yeah.
You don't need to call the trunk link under all VLANs. Automatically, all the VRFs will be mapped to VPN. All the VRF, Binku and Tinku, they are mapped to VPN. Right? See you.